All right, scholars, we are at the 2 week mark until the end of our academic exploration. How exciting! We're going to pick up with looking at the function tangent, which hopefully you remember as the ratio of sine to cosine, sine divided by cosine. So in this lesson, we're going to learn to describe the features of the graph of the tangent function, such as period, domain, and asymptotes, so I can compare and contrast in writing the features of the cosine, sine, and tangent functions. I'll know I've got it when I can explain why the tangent function has a period of pi and why the graph of tangent has asymptotes. Up first, we have a table with the corresponding values for cosine and sine at different angles of radian angles of rotation. Your first task is to calculate the corresponding value of tangent, right, using our ratio of sine over cosine, right? That represents tangent. So you have the corresponding values here and should be able to, with relative ease, complete that. And then identify two things that you notice and two things that you wonder based on the data in the table, specifically corresponding to tangent. So early in this unit, we spoke briefly about this idea of tangent, and Curly had informed us that the tangent actually represents the slope of the hypotenuse for that particular right triangle. So notice sometimes we have, right, pi over 6 would be a 30-degree angle of rotation. If we had pi over 3, it'd be more like this. So we would anticipate that the value of tangent when we rotate pi over 3 radian would be larger than that for pi over 6 because it is steeper, visually speaking. So once again, you should have done this part in your warm-up, but you'll be tasked with completing the rest of the table, and this should give you an excellent opportunity to practice your ability to recall the unit circle. Before we have a few questions. So how are the values of tangent theta like the values of cosine theta and sine theta? How are they different? Start to intertwine this idea of a period. So we've talked about what the word period and how cosine and sine are periodic functions over interval of 0 to 2 pi because they replicate as soon as we hit 2 pi. The behavior repeats. Does the same hold true for tangent of theta? Is that how it's different from cosine and sine? Is that how it's the same? You should be able to notice based on your values in the table too that there is a distinct difference between cosine and sine and tangent. Now, before we look at the graph, so you can actually visualize that distinct difference, I'd like to hear you explain why the graph of tangent theta has a vertical asymptote at x equals pi over 2. Remember, it's like a broken record and super congested because of my allergies, but tangent theta is the equivalent of this ratio. So tangent is basically a rational trigonometric function. We spent the entire last unit discussing rational functions and where we look to identify our vertical asymptotes. So I'm going to leave it at that because that should be more than enough information. And if it's not, that's fine. We'll talk about it in class or in small group. Identify any other vertical asymptotes and try to work on a interval of 0 to 2 pi here. You can obviously go on infinitely because trigonometric functions are periodic, but if we can identify them between 0 and 2 pi, we know that we can just add 2 pi to each of those angles of rotation and wind up with more multiples. We're just identifying, so you can use this table here on slide 3. But where is tangent of theta 0? Where is tangent of theta 1? And then ultimately, is the graph periodic? Here's our picture. So it looks periodic, but over what interval? So where are the vertical asymptotes? At a dashed line, right? We could dash, dash, dash. Probably wouldn't do that way. I actually probably do it this way. There's a dash, 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 so on and so forth. What are the zeros of the function? Draw points for the zeros. Where is the function positive, negative? Color the axis to show where the tangent is positive and where the tangent is negative. So in terms of the unit circle, why is tangent positive in quadrants 1 and 3? Where does that actually unfold here in our coordinate plane? And the period of the function. So I'm going to say here that the period of is not 2 pi. We do not need to go an entire 2 pi radian around the unit circle for tangent to replicate its behavior. You could theoretically sit here and calculate the tangent value for every point on the unit circle. That's a bit tedious, but you could also think about, since tangent is the ratio of sine and cosine, we really are simply concerned with the sines, which is why our first question is asking you why tangent is positive quadrants 1 and 3. What is it in quadrants 2 and 4? That should help you determine the interval for the period of the function before pausing, where we'll pick up together in class.